Okay, so we're taking a look at section 4.6, writing polynomials, which is just an extension of 4.5. Excuse me, some people call it building polynomials from the roots. I want you to take a look at page 199. It talks about the complex conjugate theorem, which is very similar to the irrational conjugate theorem. It's stating that if one of the roots is a plus bi, then its conjugate, which is a minus bi, is also a root, and vice versa. So let's do Monitoring Progress 6. It's telling us that the roots are 3 and 1 plus I square root of 5, which automatically means that you know that 1 minus I square root of 5 is also a root. So let's start building it. Remember, inside the parentheses it's the opposite. Now this one, I'm going to put it in brackets because it is x minus 1 plus I square root of 5. And then this one is x minus 1 minus I square root of 5. Okay, let's clean this up. And now you don't have to write this step. Some people don't. I like to show it so that you can remember that this is really x minus 1 minus I square root of 5, and this one is x minus 1 plus I square root of 5. Okay, now we're going to group it like we did in the last section. So if you remember, this I'm going to group together and this is going to group together. And I hope you can recognize that this is again a minus b and this is a plus b, which is really a hidden dots problem. Okay, so now I'm going to take my a and I'm going to square it. It's always going to be a subtraction. And then I'm going to take my b, which is I square root of 5, and I'm going to square that. I'm going to write it over here on the side so you can see this part of it. Okay, make sure to put brackets because we got to do that part first. So x minus 3 is here. Let's write this out. This is x squared minus 2x plus 1. Then we put our minus sign in. Okay, let's write this part here on the side. It's really I square root of 5 times I square root of 5. If you remember from before, I times I is I squared, and I squared is always equal to negative 1. So this is negative 1 times the square root of 25, which is positive 5, and then there's negative in front of it. So this expression is really negative 5. Now remember, because of dots problem, there's a subtraction here. So the subtraction means that's really adding. So here's what it looks like. X squared minus 2x plus 6. Whew! Alright, now we can finally get to multiplying it. So this is x cubed minus 2x squared plus 6x. Next one, negative 3x squared plus 6x minus 18. Okay, x cubed minus 5x squared plus 12x minus 18. This one you cannot check on a calculator because of the complex roots that it has, which is 2 of them plus 3, the real number, thus x to the third power, the degree. So now we're going to do Monitoring Progress 8, and this one is a very long problem, and you have to pay attention to detail, so you're going to want to make sure to have enough paper, and that you're probably going to want to pause the video, and then tomorrow in class you can ask me questions. So here we go. Monitoring Progress 8 has 3 roots, but if you notice, there's a complex number and there is an irrational number. So that means, because of the theorems that we've learned, that its conjugate, negative 2i, is also a root, and the conjugate of this one, 4 plus square root of 6, is also a root. Okay, let's write this out. This first one's really easy. X minus 2. Alright, so that we're going to leave aside for a bit. Now we're going to write these. It's going to be x minus 2y. I'm going to use this one, which is also x minus negative 2y. We'll clean that up to be a positive. This one's going to be x minus 4 minus square root of 6. And this one's going to be x minus 4 plus square root of 6. Now some of you are going to want to go ahead and distribute that negative. You're used to that by now. That's fine with me. So x minus 2. Now let's just clean it up. X minus 2y. This one is x plus 2y. This one is going to be x minus 4 plus square root of 6. X minus 4 minus square root of 6. Okay. Bring down the x minus 2. If you recognize this, this is a dots problem. So I'm going to square the first. I'm going to square the last. And the sign in between is always subtraction. Here I'm going to group this one like we did in the last section. And again, this is another dots problem. Let's put brackets. I'm going to square the first. I'm going to square the last. And the sign in between is always subtraction. Okay, here we go. X minus 2. Alright, so if you remember 2y times 2y, I'll do it here on the side. Let's see if I can move my camera. So 2y times 2y. That makes 4i squared. And if you remember, I squared is negative 1. So that means that this is negative 4. You might want to write that down. I squared is negative 1. Okay, so that means if this is negative 4, it's x squared minus negative 4, which we'll clean up later to be x squared plus 4. Alright, let's write this one out. I'm going to write out this problem. This is going to be x squared minus 8x plus 16, perfect trinomial square, minus 6, square root of 36. Alright, x minus 2, this comes out to be x squared plus 4. This cleans up to be x squared minus 8x plus 10. Alright, now let's continue. Move my camera a little bit so that I have some space. Okay, so let's multiply this part first, then we'll multiply it with this trinomial. Okay, this turns out to be x cubed plus 4x minus 2x squared minus 8. Alright, I'm just going to rewrite this so it's in the right order, descending order. Alright, now we're going to multiply this out. 4 terms with a trinomial. Go slowly, one at a time, so you don't make a careless mistake. Okay, first one. X cubed times x squared makes x to the 5th. Minus 8x to the 4th. Plus 10x cubed. Negative 2x to the 4th. Plus 16x cubed minus 20x squared. Next, 4x cubed minus 32x squared plus 40x. Last one. Negative 8x squared plus 64x plus 10. Okay, I'll move my paper up. Now what we're going to do is just add all of these, bring this down, x to the 5th. minus 10x to the 4th plus 30, 20 and 10 is 30, x cubed, minus 60, x squared, 40, 20 is 60, plus 104x plus 10. Oh my goodness. What an amazing problem.